we have to show that area of triangle AED times area of triangle BEC equals area of triangle AEB times area of triangle DEC. So let's call this, if we call this A1, call this A2, we'll call this A3, and finally we'll call this A4. So we're asked to find that the products, that's the opposite areas that are equal. If you multiply this, that is equal to this, the product of this. Okay, let's call the angle here theta. We know by vertical angle theorem this is also theta. Again, this is a straight line, so this should be 180 minus theta. Again, by vertical angle theorem, this is also 180 minus theta. So again, let's denote AE. You know this E. Let's call AE A. Why this is B? EC B. Again, DE, let's call it C. Finally, EB, let's call it D. So as you can see, we have SAS triangles here. So we find the area. So we now see that A1 is half the area, half AC sine theta. Do you remember? Area of a triangle given two sides and an included angle. That's it. Again, A2 is half BD sine theta. A3 equals half A3 half BC sine 180 minus theta. And we know in trigonometry, sine 180 minus theta is sine theta, second quadrant. So we have half BC sine theta. And finally, A4 is half AD sine 180 minus theta, which is half AD sine theta. A1, A2 is now half AC sine theta times half BD sine theta. Half times half is 1 over 4. We have 1 over 4 A, B, C, D sine square theta. So again, let's do A3 times A4. We have half BC sine theta times half AD sine theta. Again, we have 1 over 4 ABCD sine square theta. So as you can see, the two have the same results. So from here you can see that A1 times A2 is equal to A3 times A4. As far as this, you know, this is a trapezium. Once you multiply the two opposite areas, they are always equal to the product of the other two areas. So we've proved that. Whereas show that area of triangle AED equals area of triangle BEC. As you can see, since we have only one pair of parallel sides, means that ABCD is a trapezium. So this is a trapezium. So we have to find that, to show that this equals that. Okay, we start by drawing an auxiliary line. So assuming, okay, let's label here. Let's label DC as A. y dot this h. This is also h from the same point. So we now see that area of triangle ADC, remember, area of a triangle is half base times height. So half the base is A times height, which is h. That's the first thing we have to know. Again, if you notice, area of triangle BCD is also have A times height. See, BCD. So again, the same base is half A times h. So what do you notice? We now see that triangle, that area of triangle ADC is the same thing as area of triangle BCD. And if you look at it, you notice that the two triangles have common area. They have DEC. So assuming if I label triangle AED, the area is A1. So let area of triangle AEB be A1, while area of DEC be A2. Finally, area of this be A3, BEC. You now see that ADC is the same thing as A1 plus A2, while area of BCD is the same thing as A3 plus A2. Therefore, ADC is A1 plus A2 and BCD is A3 plus A2. So what do you notice? They have common term, which is A2. Therefore, A1 must be equal to A3, which is what we are asked to prove. A1 is area of triangle AED, while A3 is area of triangle BEC. So we ask if area of triangle PQR is 25 cm PQR. So here is 25 cm squared. And triangle S, the area of triangle STR is 9. So we are asked to find area of triangle QRT. So let's call it A. Remember, this line is parallel to this, so we can easily complete this quadrilateral. As I will complete it to form a quadrilateral. So joining PX. So we've joined PS. So what do you notice? We'll form a quadrilateral, and this line is parallel to this, even a trapezium. And do you remember from the theorem that we derived, dot of these two is always equal to this? And again, we've proved that that area PROS is the same thing as area QRT. So we now see that A times A will always be 25 times 9. So we have A squared is 25 times 9. And a is square root of 25 times square root of 9, which is 25. Square root of 25 is 5, while square root of 9 is 3. 5 times 3 is 15, so the answer is option B.